How to evaluate factorials. So let's look at this first one. 7 factorial. By definition, it's 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives 5,040. How do I get a crazy number like that? Well, if you're doing it by hand and not on a calculator, the easiest thing to do is probably to take things 2 at a time. And then times 1's not going to do anything, so it's easy to kind of just go from there. So this gives us 42 times 20 times 6. And then, of course, you could do these sort of calculations on the side. 42 times 20, 40. And then finally that times 6, which gives the same thing, 5,040. But I would recommend using a calculator. Alright, let's look at this next one. We just use the definition for a factorial for both the numerator and the denominator, so that's 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1. You could multiply the whole numerator together and the whole denominator together and then simplify that fraction, but the easiest thing to do is to actually just cancel the numbers that are the same on the top and the bottom. And then you end up just having to multiply 6 times 5 times 4, which is 120. I'm going to put a little note here. It doesn't make too much of a difference, but what you may notice is that 6 factorial is 6 times 5 times 4 times 3 factorial. Right? And that's because 3 factorial is 3 times 2 times 1. And so you could write this all sorts of ways. You could say, 6 factorial is equal to 6 times 5 factorial, since 5 is factorial is 5 times 4 times 3 times 2 times 1. The reason I mention it is because I could have written this as 6 times 5 times 4 times 3 factorial, and then left the 3 factorial on the bottom, canceled the 3 factorial, and then I would have gotten the same answer as above. And we could even use that for number 3, but maybe I'll do it both ways. So again, we just use our definition of a factorial. So 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 5 factorial, which is 5 times 4 times 3 times 2 times 1, and 4 factorial, 4 times 3 times 2 times 1. Cool. And so then again, we could just go and have a little canceling party. The 5 with 5, 4 with 4. I could have used this 4 if I wanted to, but I'm just going from left to right. The 3 with 3, the 2 with the 2, the 1s don't matter so much since it doesn't really add anything. And then you could even continue to cancel. So rewriting it gives me 9 times 8 times 7 times 6, all over 4 times 3 times 2 times 1. So you could just decide to cancel things that you see right here, and I would recommend that completely. But just to make things simple, I'm just going to pretend that this was enough for me, and I'm just going to multiply the top and get a new numerator and a new denominator, and then see if I can simplify afterwards. So multiplying the numerator together gives me 3,024, and then multiplying the denominator together, 4 times 3 is 12, times 2 is 24. But then I see that I could actually simplify this fraction, and so you could always pick something easy, like if you see that they're both even numbers, or if you know a larger number that could go in, then you could even always take a guess at that. Looking at this one, I see that I could divide the top and bottom by 24 itself, actually. And I'll kind of show you how to figure that out. And so 3,024 divided by 24 will get 126, and 24 divided by 24 is 1, so this just gives me 126. If you're happy enough with that, you can even stop the video, but I am going to show this using the same way I did the no over here, using the factorials rather than multiplying everything out. And I'm going to show you how you could reduce this a little bit more quickly than dealing with such large numbers. So for the 9 factorial, I am going to stop it at 5 factorial, just because that's the larger of the 2 factorials on the bottom, and I know that I could cancel it out. I'll multiply out the 4 factorial since I'm not going to cancel that one out. What I mean is I could do this, right? Just like I did over here. And then I'm left with the exact same thing I have over here. Rather than multiply it all together, I'm going to be a little bit more strategic about it. So I'm going to notice that with multiplication, I could do it in any order. So the 4 times the 2, I'm going to rewrite it just to make it a little bit more simple too. Is that I have this. 4 times the 2 would give me an 8. Oops, I 6. And then I have a 3 times a 1, which just gives me a 3. The 1 doesn't really mean anything. And notice now I see that I could go ahead and cancel the 8 out. You could do that different ways by just crossing out the 4 and the 8. There's a lot of different ways to do this. I also see that I have a 3 and a 6 or a 3 and a 9. So it's really kind of up to you how you want to reduce that. Sure, I'll just go 3 with the 6. 3 goes in 6 twice. So it doesn't cancel out completely. And this is a lot easier to handle because now I have 9 times 7 times 2 on the top. And I just have a 1 on the bottom. Remember, it's not a 0. After you cancel things, it's kind of left with a 1. And 9 times 7 times 2 will give me the same thing, 126.